This is a Math 30-2 set theory review on page 11 of your review notes. First, let's go through some vocabulary. A set is a collection of distinct objects denoted by capital letters and curly brackets. So you can see here we have set A with a capital letter. We've got our curly brackets, and this particular set has 1, 2, 3, 4, 5, 6 in it. Remember that you can have things such as oranges, apples, blood types, lots of different options as long as they're distinct objects. Distinct means that the number 1 would not be in there twice. It means every single number has to be different. The number of elements in a set is written as n of A. For example, that set that we just looked at with 1, 2, 3, 4, 5, 6, the number of elements in that set is 6 elements. An object in a set is referred to as an element. So all of those numbers, 1, 2, 3, 4, 5, and 6, those are all elements in the set A. We've got this symbol here that represents element of. We've seen it when we talk about domain and range notation, such as X is an element of the reals. And remember that if I put a line through it, that means not an element of. Next, we have the empty set. The empty set is a set that contains no elements, and that is designated using a circle with a line through it. Next, we have a subset. A subset of a set is a set that contains some or all or possibly none of the elements from a previously defined set. So here is our symbol for subset. And here is our symbol for not a subset. So let's just give a quick example here. So far we have set A, which is 1, 2, 3, 4, 5, 6. Let's make set B, which is going to be 2 and 3. Now, because all the elements of B are in A, we would say that B is a subset of A. So it means all of the elements of B are in A. Next up, we have the universal set. It says there is generally some larger set that we have in mind that contains all of the elements under consideration relevant to the problem called the universal set. So when we're dealing with Venn diagrams, the universal set is all of the elements within the Venn diagram. Next, we have the intersection. So intersection is the set of elements that are elements of both sets, A and B. So notice that word and here. When we're talking about the intersection, we're saying A and B, and here is the symbol for this. Now this is on your formula sheet, and when we talk about what that means in terms of Venn diagram, it means the things in the middle of our Venn diagram. So A and B is the things in the middle. So if I had two sets, I had set A, which was 1, 2, and 3, and I had set B, which was 3 and 4, the intersection A intersect B would be 3, because 3 is in both of the sets. Okay, next up we have the union. The union is a set of elements that are elements of either set A, set B, or both, and denoted by A, big U, B. So here, notice that word or, and then of course we have our union symbol. When we look at a Venn diagram, that means we are now considering everything inside any of the circles. So using that previous example, A union B, you would take everything from A, 1, 2, and 3, and you would add the elements from B in there that have not already been there. So A union B would be 1, 2, 3, 4. Okay, disjoint sets are two sets that have no elements in common. So if we were to think of a Venn diagram, they would be completely separate. No elements in common. We also call this mutually exclusive when it came to probability. Okay, and then natural numbers. These are just things that you might need to know for set theory questions. So our natural numbers are our counting numbers. So that means if you were to start counting, you would say 1, 2, 3, 4 for playing hide and seek. Uh, those are our counting numbers. They do not include 0. If we want to include 0, we now call them whole numbers. So 0, 1, 2, 3. No negative numbers. If we want negative numbers, now we call them integers. So negative are positive and negative whole numbers. We also have something called a multiple. Multiples are the result of multiplying a number by an integer. For example, the multiples of 3, 3, 6, 9, 15. So you can think of it as skip counting by the number that you're looking for. Okay, on the next page, we have two more. We have factor. Factors are numbers that you can multiply together to give you other numbers. For example, the factors of 15 are 1, 3, 5, and 15. 1 times 15 equals 15, and 3 times 5 equals 15. There are no other factors of 15, just those ones. And then our last definition, if a number is if its only factors are 1 in itself, then we have what's called a prime number. So remember that 1 is not a prime number, it starts at 2. 2, 3, 5, 7, 11. Okay, let's get started with some examples. Consider the following Venn diagram to answer the questions. So here we've got a 3-circle Venn diagram, and I do notice that there are dots after each of the numbers in the Venn diagram. That means that they are elements in the set rather than denoting how many items are in the set. Okay, so first question says state U. So that U, that's representing the universal set. So I need to list everything in all of the circles, including the outside. So I see 0, I see 1, I see 2, I see 3, I see 4, I see 5, I see 6, 7, 8, 9, 10, 13, okay, 5, 6, 7, 8, 9, 10, 13, 15, 17. I can see here that I didn't quite leave enough space. All right, next we have A union B. So remember, A union B means everything in A and B. So we include all of the circles. So I'm just going to highlight what we're going to include here. Everything in A and everything in B. Okay, C is not part of this at all, so essentially we can ignore it. So I'm now going to make a set with everything in A and everything in B. Okay, I'm going to do it above here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we have the number of elements in A union C. So now instead of considering A and B, we're considering A and C. So I'm going to change my highlighting color. It's going to be everything in A and C. So I'm going to count up those numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 elements, which is what that N at the beginning stands for, the number of elements. Okay, next one, A intersect C. So I'm now going to find A and C. So when I look at my Venn diagram, A and C, it's everything in the middle between those two sets. So just going around it with the outside. 3 and 5 are part of that set. Okay, now we have A intersect B intersect C. So now we're looking for what's in all three sets, the intersection of all three, and that is just going to be 5. Okay, notice for all of them that I'm using my curly brackets, putting commas between my elements. All right, the last question here says state A intersect B intersect C, and then we have that little ticky thing. So this would be a good time to add that up here. Complement. Okay, so complement is denoted by a tick or an apostrophe after our set, and it means everything not in A. So for this one, it means everything not in the intersection. And we just found the intersection, right? That was 5. So it's going to be absolutely everything other than 5. So I'm just going to take a second and write out that set. And that does include the outside of the Venn diagrams, which is 0. All right, let's move on to the next example now. It says if A is 3, 6, 7, 8, and B is 5, 7, 9, and 10, what is the set A intersect B? And determine the number of elements in A union B. Okay, so let's start with A intersect B. A intersect B means A and B. So when we're talking about the elements, we're talking about what elements are in both of those sets. So the element that I see that's in both of them is 7. Everything else is unique. So A intersect B is 7. Okay, now let's do N of A union B. I'm going to start by listing A union B, just so that I don't make any mistakes. So start by writing down A and including the elements from B as we go. So 3, 5, 6, 7, 8, 9, 10. And then the number of elements, of course, we'll just count up how many there are. So 3, 6, 7. Great. Next example. A class of 25 students was surveyed to determine the type of music they enjoy, alternative or pop. The results of the survey are illustrated in the partially completed Venn diagram below. So I see A, I see P, and then we have a bunch of statements. Frida made the following statements. A is a subset of P complement. So remember that means all the elements of A are in P complement. So P complement is everything not in A. So I'm going to just take a moment to color P complement. everything outside of P. So really it's just that 5. So what we're saying is all of A is in P complement. So did we shade all of A? No, we missed that 3 in the middle. So this is a false statement. Next statement says P union A equals 21. So remember that the union means or, which means that we add up everything inside the circle. So 8 plus 13, and that does equal 21. So that's a true statement. Automatically, I can tell that that next one's going to be false because the intersection is not the same as the union. The intersection is going to be just 3, just the middle of those two sets because it's denoting and. And then the last one, hopefully it's a true statement. Let's double check. P union A, the complement of that. So P union A, once again, is everything in the middle. And we need to figure out how many elements are on the outside because the Venn diagram wasn't actually completed. So to find out the outside, we're going to take the number of students, 25, and we're going to subtract all of the center of the Venn diagrams, which we know was 21 from statement number 2. So that does give us 4, which you betcha, that is that last statement. So my answer, statement 2 and 4 is correct. Moving on to another example. Students were surveyed about the activities they would like to do in phys ed. The results are given below. So we can see there's weight training, cross country, and then, combinations of these two things. So immediately when I see questions like this, I start thinking about a Venn diagram as the best way to represent this information. And in fact, you have to do some kind of Venn diagram if you want to be successful in these. Okay, so I'm going to label them as weight training and cross country. So the reason that you have to do a Venn diagram is this 34 cannot go directly into the Venn diagram. Remember that you want to start in the middle of your Venn diagram wherever possible. So in this case, we do have weight training and cross country as 13. So that can go right in the intersection. Now that 34 we were talking about, we can take 34 and subtract that 13, which is 20, 21, to give us our weight training. Now notice that everything inside my W circle adds to 34. Okay, let's do the same thing for the cross country. For cross country, we have 39, but we have to subtract the 13 because those have been included in there. So that's 26. Okay, let's check that last one now. It says neither weight training nor cross country. So there's some people who don't have an interest in any of them, and that is represented by the outside of my Venn. So once I have made my Venn, it is substantially easier to answer the questions about it. So it says the number of students in the universal set. Universal set means we add up everybody in the Venn diagram. So 28 plus 21 plus 13 plus 26. 88. Notice that there's not really a way that we could have got that number from the original table. So putting it into our Venn diagram is very important. Okay, the next question says the number of the students who would not like to take cross country. So when we look at our Venn diagram, that's the complement of cross country, right? It's everything outside of cross country. In this case, that is represented by 21 and 28. Both of those numbers, those people don't want to take cross country, and that is 49. And then lastly, the number of students who would like to take weight training or cross country. Remember, or is the union, so everything inside our circles, which means we're going to take 21, we're going to add 13, and we're going to add 26. 60. So once again, these numbers cannot be found unless we make a Venn diagram.